In this video, I want to talk a little bit about related codes to piping and a little bit about trade math, because piping is an area we do have to use some math in. So let's first talk about some related codes. These are taken from international mechanical codes. The code in your jurisdiction may be a little bit different, but these are basic principles that are used straight across the board. First of all refrigerant piping shall be installed, tested, and placed in accordance with code. Okay, the word shall in code means you will do it that way. There's no options. Piping enclosures, okay, shall be provided for soft annealed copper tubing and used for refrigerant piping erected on the premises containing anything other than Group A1 or B1 refrigerants. So thinking about refrigerants, Group A1 means non-toxic, non-flammable. B1 is mildly flammable, but non-toxic. Okay, so again, we need to be worried about the refrigerant pipings that are other than A1 or B1 refrigerants. All refrigerant piping and fittings, brine piping and fittings that during normal operation reach surface temperatures below the dew point of the surrounding air are located in spaces where condensation would cause a safety hazard to the building occupants, structure, electrical equipment, or any other equipment shall be protected in an approved manner to prevent such damage. In other words, if the surface of the piping is below the dew point, in other words, condensation can occur, things have to be done to protect it from that happening. Most often, we use pipe insulation to prevent that. Okay, materials for piping and tubing, we can use steel pipe. It's a carbon steel pipe with wall thickness not less than Schedule 80. That's used for Group A2, A3, B2, or B3 refrigerant. Liquid line sizes for 1.5 inches or smaller. Carbon steel pipe with wall thicknesses not less than Schedule 40 should be used for A1 or B1 refrigerant liquid line, 6 inches or smaller. Okay, Group A2, A3, B2, or B3 refrigerant liquid line sizes 2 inches through 6 inches, and all refrigeration suction and discharge lines of 6 inches or smaller. So in other words, we're being told what schedule piping should be used for the different types of refrigerant. Copper tubing. Okay, copper tubing used for refrigerant piping erected on the premises shall be seamless copper tube of type ACR, can be hard or annealed, complying with ASTM B280. Where approved, copper tube for refrigerant piping erected on the premises shall be seamless copper tubing of type K, L, or M, drawn or annealed in accordance with ASTM B88. Annealed temper copper tubing shall not be used in sizes larger than 2-inch nominal size. Copper tubing joints. Copper tubing joints used in refrigeration systems containing Group A2, A3, B2, or B3 refrigerants shall be brazed. Solder joints shall not be used in such refrigerating systems. Again, pressures of solder joints you can't use solder joints over 300 psi pressure, and if there's a fire, which is what we're worried about with the 2-3 type classification, the flammability classifications, okay, we need to be very concerned about melting temperatures. Solder is a very low melting temp. Aluminum tubing. Type 3003-0 aluminum tubing used with high pressure fittings shall not be used with methyl chloride or other refrigerants known to attack aluminum. Okay, joints in refrigerant containing parts of the air ducts. Okay, in other words, if it's going through an air duct, joints in all refrigerant containing parts of a refrigeration system located in an air duct of an air conditioning system carrying conditioned air to and from humanly occupied space shall be constructed to withstand without leakage a pressure of 150% higher than the design pressure relief valve setting. Okay, they're worried about the pipes leaking, the fittings leaking into the airstream, okay, and contaminating the air people are breathing in. Some refrigerants cannot be breathed in. Exposure or refrigerant pipe joints. Refrigerant pipe joints erected on the premise shall be exposed for visual inspection prior to being covered or enclosed. In other words, you don't cover these piping without it being inspected. All refrigerant containing more than 6.6 pounds of refrigerant in systems using positive displacement compressor shall have stop valves installed as follows: at the inlet of each compressor, compressor unit or condensing unit; at the discharge or outlet of each compressor, compressor unit or condensing unit; at each of liquid receivers. In other words, there has to be a place to valve off the system. Systems that have a refrigerant pump out function capable of storing the entire charge in a receiver heat exchanger is an exception to the valve requirement. Systems that are equipped with provisions for pump out of the refrigerant using either portable or permanently installed recovery equipment is an exception to the pump out requirement. Self-contained systems do not have to have the valves in that exact place. Okay, so those are some of the codes. Now, let's talk a little bit about the math requirements here, okay, because we're dealing with fractions. Okay, so we need to be able to convert to and from fractions and decimals. Fractions such as 2/10 and 0.2 are both read the same, 2/10. When there's one digit at the right end of the decimal point, we read the decimal as tenths. If there's two digits to the right, the decimal is a hundredth, and three digits is thousands, four figures is in 10,000ths. So we have some fraction decimal conversions. So 1/10 or 0.1 is still 1/10. 1 over 100 or 0.01 is 100th. 1 over 1,000 or 0.001 is 1,000th. 1 over 10,000 or 0.0001 is 1/10,000th. Okay, so a couple exercises. First one, okay, write the following common fractions as decimal. Number 1, 3 over 10 is 0.3. Okay, and then you do the rest of these. Okay, 75 1,000ths, 31 10,000ths, 46 100ths, 888 1,000ths, 72 100ths, and 82 1,000ths. It's just a matter of converting the decimal to 0.3, 0.075, 0.0031, 0.46, 0.888, 0.72, 0.082. Okay, it's basically moving the decimal point. So, a dowel is 0.5 inches in diameter. Okay, what is it in fractions? It's a half inch. A strip of sheet metal is cut so it's 0.907 inches wide. Go ahead and convert that to a decimal. I'll give you the answers in a minute. The thickness of a template is 0.145 inches. An insulated wire has a diameter of 0.091 inches. The insulation around a wire is 0.0305 inches. Okay, so the first one is 5/10. Then we have 907 thousandths. We have 145 thousandths. We have 91 thousandths. And we have 305 10,000ths. So those are just some basic, easy decimal fraction conversions. And you get more complex from that point.